A good Tuesday morning, ladies and gentlemen. In part 4 of One Way ANOVA, we shall start talking about local tests that we need to run after the overall ANOVA is significant. I want to clarify that if the ANOVA is not significant, we cannot perform the local test at all. Why? The answer is if ANOVA is not significant, it tells us that there is no a significant difference between any groups. Therefore, we should stop here and write up the final results for our study. But as p-value is less than 5% in our case, we want to know which cohort or group differs from one another. Therefore, post hoc tests come in handy. I just introduced another concept called post hoc test. What does this concept mean? Well, it is in fact a local test that we need to run if the global ANOVA is significant. We can say it is just another term for the local test. There are many post hoc tests to choose from, ladies and gentlemen, but we are going to use the common one called Turkey HSD. We use Turkey HSD because assumption number 2 is not violated. Again, we need to run Turkey HSD in order to verify which group significantly differs from one another. And we use it because assumption number 2 of ANOVA is not violated. What do we mean by assumption number 2 is not violated? Well, as you may recall, it means variances across all groups are equal. Let's go to SPSS and run the post hoc Turkey HSD together, ladies and gentlemen. So we go to Analyze, Compare Means, One Way ANOVA. We move Final History Score here. We move Cohort of History Students here. Before we click OK, we click on Post Hoc. And under Equal Variances Assumed, we click on Turkey. Please note that there are so many local tests when equal variances are assumed, but the research community, scholars, agree that Turkey is very, very good. So you see the significant level is set at 5%. Continue. Okay. So SPS generate one-way ANOVA for us, one-way ANOVA here, significant. This is a post hoc test. Specifically, we perform Turkey HSD. And this is the homogeneous subsets. Let's learn how to read all the numbers here. As you can see, ANOVA is very significant. Then let's go to multiple comparisons table. You can see here the note here that you can see the note here. It indicates Turkey HSD because we have just performed it. Since we have only one dependent variable in our study, you can also see dependent variable here that says final history score. I am sure if we have more than one dependent variable, we shall see all of them listed here. Well, ladies and gentlemen, let's get into reading some happy numbers over here. They are happy numbers, very important numbers. As you can see, on average, (2018) cohort performed 12.53 points lower than 2019 cohort. As you can see here, 2018 cohort mean score minus 2019 cohort mean score. So this is huge. This is big. And if we continue to the p-value, it is very significant. What does this all mean then? It means that there is a significant difference between cohort 2018 and 2019 on their final history score. In other words, cohort 2019 scored higher than cohort 2018. If you go down the row that compares 2018 with 2020 cohort, 2018, 2020 cohort, again, cohort 2018 score 3.91 points on average, lower than cohort 2020. And please do not stop here, ladies and gentlemen. Please move further to find the p-value. The p-value is 0.234, which is greater than 0.05 or 5%. So the two cohorts did not perform differently on the history subject. SPSS generates duplicates here. So we need to skip this row. I would like to skip the second row and let's go to the last row. Let us look at the last group, in this case, between cohort 2019 and 2020. Well, cohort 2019 score 8.62 points higher. And if we go to the p-value, it is 0.005, much lower than 0.05 or 5% that we need in order to reject the null hypothesis. In summary, ladies and gentlemen, among the three pairs, one pair is not significantly different and two pairs are significantly different from each other. We are almost done with reading and understanding all the happy and exciting numbers of ANOVA, ladies and gentlemen. We need to go through the last table only. Here you can see the homogeneous subset table. What is that? What is that? Well, it is quite interesting. As you can see, scientists before us are very smart. Since the sample sizes of the three groups are not equal, SPSS makes some adjustments for Turkey HSD post hoc test, you see the sample sizes for the three groups are not the same, are not equal. As you can see, the mean score for cohort 2018 is 66.37, for 2020, 70.28, and for 2019, 78.90 out of 100. Since the means for cohorts 2018 and 2020 since the means for cohorts 2018 and 2020 appear together or bundle together as a subset here, both cohorts did not significantly differ from each other. And I would like to repeat, since the means for cohorts 2018 and 2020 appear together or bundle together as a subset here, both cohorts did not significantly differ from each other. That's how we, digest or understand or make sense or comprehend the homogeneous subset table. When there is a subset like this, it simply means both groups did not differ on the history subject. Let's continue. However, ladies and gentlemen, the mean score for cohort 2019 is all alone. Its mean score is 78.90. It is all alone and really alone. No mean score of another group comes together with it. This tells us that 2019 cohort performed differently from the other two cohorts on the history subject. A bonus tip here, ladies and gentlemen, if you compare this subsets table with the multiple comparison table above, the results are exactly the same. It is fortunate that they are not different. What if they are different? Well, we are going to use the adjusted results in the homogeneous subset table. Well, ladies and gentlemen, we are ready to move to displaying data in a table or two and report writing. And I will see you again so soon.